Hello student. This is one heterocyclic compound, that is pyridine. This is the structure of pyridine. Benzene ring. One methylene group of benzene ring is replaced by nitrogen. This is the general formula of pyridine, that is C5H5, or molecular formula of pyridine, that is C5H5N. It is also known as nitrogen is called as aza. So aza benzene, and pyra plus for 6-membered iridine, that's why pyridine. It was first obtained from bone oil and coal tar in 1849. It is basic because of presence of nitrogen. Basic heterocyclic compound, structurally related to benzene. Of course, one methine group is replaced by a nitrogen atom. It is colorless liquid. Boiling point, its boiling point is 115 degree centigrade, having fishy odor. See how you can nomenclate and classify this compound. First you have to write ring size, or you can say stem part. Ring size is 6-membered ring, and for 6-membered ring we use IR. Nature or type of the ring is unsaturated ring. Heteroatom present is nitrogen. So how you can nomenclate? Pyra plus iridine is pyridine. Now these are the general method of preparation. The first method is from acetylene. 2 moles of acetylene plus hydrogen cyanide. These two reacts in red hot tube and forms pyridine. See, 2 moles of acetylene contain 4 carbon, and fifth one is from this cyanide group. Then second one is from tetrahydrofuryl alcohol. 1, 2, 3, 4. All hydrogen or all carbons are saturated. That's why it is tetrahydrofuryl CH2OH. Here second position CH2OH is present. That's why it is furyl alcohol. Furyl alcohol reacts with ammonia in presence of aluminium dioxide at 773 degree Kelvin, forms pyridine. Now here in this case already 4 carbons are there, and fifth one is present in the side chain, right? And we required nitrogen heteroatom, so we used NH3, and this Al2O3 is catalyst. Now the third preparation or third synthesis is from pyrrole. This is the structure of pyrrole. Pyrrole reacts with dichloromethane and ethoxysodium. With the removal of ethanol and sodium chloride, it forms pyridine. The fourth preparation is from picoline. See, pyridine ring, and at third position methyl group known as, see, after nitrogen atom this one is alpha position and C3 is beta position, right? So this is beta picoline. This is the structure of beta picoline. Now oxidation of beta picoline, we will get pyridine 3 carboxylic acid, and in presence of calcium oxide there is removal of CO2, and we will get this pyridine. So 4 method of preparation. First one is from acetylene, second one is from tetrahydrofuryl alcohol, third one is from pyrrole, and fourth one is from picoline. Next important one comment can be asked from this. Electrophilic substitution reaction. See, the pyridine ring is less reactive towards substitution reaction. It undergoes nitration and sulfonation, but in drastic condition. It do not undergo Friedel-Crafts acylation reaction. Here in case of substitution, if occurs, it will occurs at beta or third position. Now why this ring is lesser reactive towards this substitution reaction? So let us understand. See, this nitrogen atom which is present in ring is more electronegative, so it will attract the electron cloud towards it. So the rest of carbon will be having lesser electron density, right, and they will become more positive. So electron loving group is electrophile and it will not substitute this hydrogen atom because already the carbon is having positive charge, as all electrons are more attracted towards the nitrogen. That's why this ring becomes lesser reactive towards the substitution, electrophilic substitution reaction. Then second reason may be protons of acid attracted strongly by the nitrogen atom of the ring when we react this pyridine ring with HNO3 and H2SO4 for nitration and sulfonation. So, as this H plus and this N negative will react with each other and forms pyridinium ion, right? So, positively charged nitrogen will attract electron cloud. Here, this positively charged nitrogen will attract electron cloud towards it, and that's why again the next all carbon becomes lesser reactive or becomes slightly positive and less denser in electrons. Still, some reactions take place at restricted conditions are electrophilic substitution reaction. Here sulfonation, bromination and nitration takes place, and this electrophilic substitution reaction takes place at C2 carbon, which are the reagent required for sulfonation. H2SO4 and 623 Kelvin temperature is required. For bromination 573 Kelvin and bromine molecule required, and for nitration 573 Kelvin degree temperature and KNO3 in H2SO4 is required. The product formed is, in case of sulfonation, it is pyridine 3 sulfonic acid, then 3 bromopyridine and 3 nitropyridine. Pyridine also undergoes nucleophilic substitution reaction at second and fourth position, but more commonly at second position. The one important reaction is Chichi-Babin or the Chichi-Babin reaction. It is amination, nothing but amination of the ring. Here we use sodium amide, and at 375 Kelvin degree temperature, the more negative atom will react with positive part of the sodium amide, and NH2 group will attach at second position of the ring. Again, in presence of NH3, this Na plus will be removed and we will get 2 aminopyridine. Now some typical reactions, which are they in presence of potassium hydroxide at 300 degrees centigrade, it will form pyridine 2 ketone. Then with phenyl lithium at 383 degree Kelvin, it will form pyridine 2 phenyl pyridine. Then with butyl lithium at 383 Kelvin temperature, it will form 2 butyl pyridine. Now it also undergoes reduction reaction. How it undergoes reduction reaction in presence of platinum and sodium metal and this base C2H5OH, that is ethanol, it will get converted to pyridine. See, nitrogen plus hydrogen, benzene ring, here all the carbons of the ring, pyridine ring is saturated with the hydrogen. That's why it is a reduction reaction. Now using Hi red phosphorus at 573 Kelvin degree temperature, we will get normal pentane plus NH3. Sodium, so in presence of sodium metal, ammonia and ethanol, we will get the product which named as 1,4-dihydropyridine. Now next is oxidation reaction. We are using perbenzoic acid as a reactant. Now this reactant reacts with pyridine and form pyridine and oxide plus benzoic acid. Free radical reaction. This pyridine in presence of C6H5COO twice, it will form 2-phenylpyridine and 3,4-phenylpyridine. This is the structure of 2-phenylpyridine. Okay. Now what are the application? Vitamin B6, that is niacin, benzene ring, and at third position COOH group. Pyridine ring, and at third position COOH group. This is also known as pyridine 3-carboxylic acid. Now second one is some anti-tubercular drug, that is INH or isoniazid. Pyridine ring attached with amide group and one amino group, right?